The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Well, it just clicked over to 10 o'clock, so I guess I'll get started. Good morning. I hope you're here to see something about flash file systems, and we'll do our best to dig into this a little bit and see what we can come up with. My name is Dwain Sims. I think I've presented at Southeast Linuxfest probably 6 or 7 times over the years. I haven't really been keeping track too much. Have just retired from SUSE. I was working for SUSE up until the end of January, and I decided to retire. That's worked out well so far. Enjoying that. But still trying to keep my hands a little bit dirty anyway. Playing with some of this fun stuff. So, how many folks have ever heard of the F2FS, the flash-friendly file system? So that's sort of the impetus behind this talk. I had gotten, when I was still working for SUSE, I had gotten somewhat of a reputation as knowing something about storage and storage devices and things of that nature amongst some of my team. And whenever a question like that would come up, they would inevitably contact me. And I got a Slack message one day that basically said, I got a customer asking about flash-friendly file system. Do you know anything about it? And my response was, I don't know anything about it, really. And because I had heard of it, but I had never played with it or messed with it or anything. So I didn't know a lot about it. So I did learn that SUSE did not support it. So it was like, well, it's kind of a moot point for a SUSE Enterprise Linux customer because you don't want to run an unsupported file system. That would not be a smart thing to do. So that kind of put that to bed, but I sort of kept this thing in the back of my head as like, well, maybe I should go out and learn a little bit more about this flash-friendly file system. And so that's kind of what prompted me to do this. I was like, well, this is a perfect thing. I could just do this for Southeast Linuxfest, and I can show them what I learned, and we'll kind of dig in. So the flash-friendly file system was originally developed by Samsung. It's been around a few years. Going back, the history on it's kind of murky. If you go looking up online, there's not really like a website or anything devoted to F2FS. But I went back and read some of the early docs, and it looks like they really probably started working on it around 2005 or so. This fellow named Jae-yuk Kim was the principal engineer on it, and did a lot of the early work. I'm not sure if he's still working on it or not. It got in the kernel around 3.8. So it's been around in the kernel for a little while. So that's been a good thing. And at least like to me, it's much older than it actually appears. So I thought it probably had started, they had started working on it around maybe 2010 or something like that, but it goes back quite a bit further. Where most people will interact with flash-friendly file system is in an Android phone or an Android tablet. Almost all the players have picked it up there, which keep that in mind as we go through this process. So there's something about that I haven't quite figured out yet. But there's a number of folks actually doing active development work on it. So Samsung and Motorola, which is basically part of Lenovo now, Huawei and Google are all working on this. So it's got some pretty good backers that are pumping stuff into it. So the question that I was trying to answer though was, okay, great, they could use it on an Android phone. So my Android phone right here, so that's great. But should we be using it for standard workloads? Should we be starting to experiment with actually running it in data centers or at home on laptops or those kinds of things. And so I just wanted to dig in and see, how does this thing perform? How does it work? So I thought I would go back again, going back to my past. I worked for this company right here, Fusion.io, back a few years ago, and I worked for SanDisk. And having done a bunch of work in that area of actually testing storage devices, I still had a bunch of my old FIO files around. Have anybody in here messed with FIO? Are you familiar with FIO? We'll dig into that in a second here too. So I had a bunch of my old test files still sitting around that I used to use when testing Fusion.io devices and other devices, when we would experiment with different things to try to understand, what are the performance limits of these things. One of the things that we did though, when I was testing, was working for Fusion.io and SanDisk, we would avoid file systems. File systems just introduce noise to the process. So whenever we would test without the file system there at all. We would just talk directly to the raw device. That way, then you're not getting any of that noise in there about the file system. When folks would come to us and say, what file system should I use on, say, a Fusion.io device? And we would come back and almost always answer XFS, because the company had done some work on file systems and it determined more or less that XFS was you got pretty good performance out of that. You got pretty good stability out of that. And that's what we would always recommend to customers that would come along and say, what file system should I use? We would just point them at XFS. But if you really want the best performance out of the device, use it as a raw device. Most databases and things of that nature, we were talking about Ceph here before we got started, things like Ceph, they can talk directly to the raw devices. That's a better way to do things. Let the overall application sort of handle how it talks to the storage. That's probably a smarter way to do it. File systems are great. You have to use them, but if you want the maximum performance out of your devices, that's the way to do it, is to get the file system out of the way. To go back to FIO, I actually did a talk here at Southeast Linuxfest in 2018 on FIO. You could probably go back and dig that up if you wanted, but I just stole this slide directly out of that presentation. So FIO is the flexible I/O tester. If you've never used it, it's completely open source. You can use it to simulate just about any kind of an I/O workload. Even really strange ones. You can come up with just about anything you want. There are standardized tests. I know that Fusion.io came up with to test for all different kinds of standard things like maximum latency, the best bandwidth, what is the maximum throughput that you can get from the device, random and sequential. So you can do all those kinds of things. You can also blow away whatever's on your device. So that's why I put there, power tools can injure. You can wipe out whatever's there. So be careful, because it will go off and you can use it to cut your hand off. That's for sure. So just be careful about that. But FIO, if you're messing around with storage, FIO is your best buddy. It really helps you out a lot. And you could test just about anything. I mean, even network devices and things like that. If you introduce network latency into the process, FIO can help you measure what that looks like, from the actual endpoint. So it's a really good tool. Again, open source. Jens Axbo is the primary maintainer of FIO. He's a former Fusion.io employee, so I never actually met him, but I have talked to him on the phone a couple of times. Very nice guy. So I started digging into this, and I thought, well, let's go and see what we can do about figuring out this friendly file system. So my test bed was a custom build that I had done back several years ago. Still pretty nice machine though. It's an 8-core Ryzen system. It's got 16 gigs of memory. It's not nothing enterprise class or anything like that, but much easier to. I've got some servers at home. It's so much harder to reconfigure them to do things like this. So I just decided to use this guy because I could just pop things in and out very easily, and Linux would recognize them and not have to go through storage controllers and all that kind of stuff and introduce all kinds of cruft to the process. So I just kind of left that all out. So the two SSDs that I decided to use were some things that I had left over from my SanDisk days that were still sitting around. These are enterprise class devices. I had a CloudSpeed Eco Gen 2 480 gigabyte drive. That's a SATA. I also had some SAS drives around, but I didn't have a SAS controller in this system, so I didn't actually move over and try any SAS drives. I also had an HGST SN200, which is an NVMe device that's a PCIe add-in card. Now, I would bet a lot of you probably always think of NVMe drives as these little M.2 devices. NVMe can come in many forms, and NVMe also comes in the form of a PCIe add-in card, so you can just pop it right into the machine. And I had some of these, and I popped one of those in to do that part of the testing as well. So the file systems I chose to test were F2FS, of course. We're going to check that one. We're going to measure it against XFS, ButterFS. And then later on, I stopped and I thought, maybe I'll go ahead and do ext4 just to be thorough and make sure that that's okay. Probably would not have been my first choice to do, but I decided to go ahead and do ext4 as well. So I'm going to take a breath here. Any questions? Anybody? It's okay. And I should have said before I started, I'm very informal about this stuff, so just interrupt me at any time, and I'm very cool with that. So that was my sort of my test target there that I was going to go with. I decided to use OpenSUSE Tumbleweed. I will get back to that in a second, why I chose that. The kernel is 6.14, so it's a fairly new kernel. And then I had to add the FFS tools to the mix so that I could actually use the flash-friendly file system, because it's not really part of the mainstream system on an OpenSUSE system. So that was my initial start there. So I did get off to a bit of a rocky start with this. I was going to use OpenSUSE Leap 15.6. And I thought this will be great, no problem. I did the same processes. I added the flash-friendly file system tools to it, did all that kind of fun stuff. It was actually in the repo. I was able to build my file systems on my devices, but when I went to mount them, no support in the kernel. So that was a bit of a problem. So I couldn't mount my file systems. But I stopped and thought about it later. Is like, yeah, that kind of makes sense, because OpenSUSE Leap is really it's really more of a clone of SUSE Enterprise Linux. So it's more of whatever's going on in SLES. And it's understandable they would not have added that support in the kernel that they put on that system. So it was like, yeah, okay, that's fine. So I went back and reloaded Tumbleweed. Tumbleweed is much less opinionated about such things, and it had support for the flash-friendly file system in it, so I could actually do that. And that's why I wound up choosing to go back to Tumbleweed. So had to take a step back and get going again here, but it worked out very well. So I started testing first with uncompressed versions of the F2FS file system. You can compress or not compress. And so I thought, well, I'll try the uncompressed versions first. So this is where we get into the, what's going on here? Like I say, Mick Jagger always would sing, you can't always get what you want. In this case, I was not getting what I was expecting. So as we dig into this more, you'll see what I mean here. Now I'm going to stop for just a brief minute. I'm going to do a commercial plug here for just a second. If you've looked up here at the front, you may have noticed I have a mechanical keyboard laying up here. If you get a chance after we are done here, come up, take a look at it. I don't know if anybody here is interested in mechanical keyboards or not. I wasn't really that much interested till this company here, KeyBio, they came to Trilug last month and did a presentation, and they're actually in Durham. So they're a local company that builds mechanical keyboards. They have a small, I won't call it a factory. That would be overkill. It's like a workshop that they have over in Durham. There were 3 people there working the day I was there, and they built this keyboard for me to my specs, and they did a very good job on it. And they sent some toys for all of us to have. There's some stickers and some keychains up here if you would like to have one. But if you're interested in a mechanical keyboard, I would urge you to go out and take a look at key.io. So there's the end of my little plug. So I told them I would give them try to drum them up some business, and I did that. So now let's go ahead and dig into the box score of the what was going on here. Sorry for the eye chart. I'm going. All these slides will be made available so you can grab them later. So don't fret too much about this. So I started testing, and let me show you how I laid this out. So you'll notice over here I've got the columns sort of labeled. So the blue column here is F2FS. The dark blue, so these two, both of these are F2FS tests. The green is XFS, the pink is ButterFS, and the purple is EXT4. So again, this thing kind of grew because I added the ButterFS and EXT4 as I went along, just to be complete about this whole thing. And I started testing various things. And the tests that I was running are random writes for latency. So how long does it take for the thing to respond when I do a random write? That's usually what slows you down the most when you're talking, especially about a hard disk. Hard disks of a spinner will have really terrible write latency, or especially on random writes. So that's the thing that will slow you down the most. And I started testing. So initially, I'm getting this number here, and it's sort of better than all these others. And I'm thinking, hey, this is working pretty well. This is pretty nice. Then I went in to see what the peak IOPS, how many IOs per second can I do with this device? And again, this is random writes. And so I was doing this here and making that adjustments all the way across. And in this case, the EXT4 was the winner for that. And then as and again, I'm testing right now. I'm testing on the CloudSpeed Eco, which is a SATA device. Going on down, you can see peak bandwidth. I get better on XFS, so random read latency. I'm getting best on XFS. I'm getting best on random IOPS or read IOPS off of XFS as well. But when I come to the peak bandwidth, you'll notice they're all pretty much the same. Why is that? Why would they all be the same? It's SATA. SATA basically is that's as much as you could push through with SATA. And so that's your bottleneck that you're going to run into. And if you come right across and you go into NVMe, pretty much everything's the same on NVMe as well. So it's how many ever PCIe lanes that I actually had available to this device. That was what I was running into as the peak in that area. So, but it's interesting that you would see that pop up. And I know that back in my Fusion IO days, we would run into that too. That you basically would saturate the PCIe bus at some point, and that's all you could get. So, and sometimes we would push the boundaries in other areas, but usually that was the place you would hit, especially when you were doing read IOPS. So anyway, I do all this tests across NVMe and the SATA device, and they're kind of all over the place. but you notice that the flash-friendly file system doesn't win very many of them. That was not what I was expecting at all. I was expecting to see the flash-friendly file system to be slightly better on all these things, since they built this file system from the ground up to talk to Flash. It's like, wow, that's funny that it's not as fast as I thought it would be. And generally XFS, especially on NVMe, was kind of the winner. And you could argue that ext4 was the winner on the SATA device, but it was interesting as you push through. So I did not. Yeah, I did. I was just testing with enterprise style flash devices that I had. I didn't go out and buy anything new to test against. So anyway, I got through doing all this, and I was like, okay, well, that's interesting, but I wasn't expecting that. So I went back and I said, maybe if I test against like a good flash drive, that you plug in via USB. And so I ran that thing through a series of tests as well. And again, it was mostly the XFS was proving to be the fastest in that area on that device. I wasn't seeing anything really remarkably different when I ran F2FS, either compressed or uncompressed, against the flash drive as well. So I was like, well, that was not what I was expecting at all. So I didn't feel like I proved too much by doing all of that when I got done. So what do we make of this as we go through the process? What was I actually expecting? I thought I would see small but somewhat significant differences between F2FS, and the other file systems. That was not what I was seeing. I was seeing basically better, as good as performance or better performance out of XFS or ext4 most of the time. And I was like, well, that's not what I was really expecting at all at this point. So I wasn't seeing, really any better performance at all on desktop or enterprise style workloads across these things. Well, why did this happen? I don't know exactly. One of the things, the tester's an idiot. That's quite a possibility that I don't know what I'm doing, but I have been playing around with this stuff for a while. So it's like I wasn't doing anything remarkably different about what I was doing. I thought, well, maybe there's a whole new array of options that I need to pick, but I went out and I did a little bit of research on these, and I found what appeared to be the consensus of these are the mount options and the build options you should use when you're building your file system. And then I stopped and thought about that for a second and was like, wow. Okay, so I play with this stuff a lot. I've played with this stuff a lot, but most folks are not going to deal with that. They're just going to put a line in FS tab and mount their file system. They're not going to go out and try to learn a whole new set of mount options every time that they build a file system or whatever. So that's maybe I'm okay doing what I did. You could argue that my test bed's just too old. And that's probably not a terrible argument, especially on the NVMe device. The way that NVMe works, the faster your system, the faster the storage goes. And that's for sure. You're not limited by the controller speed or anything like that. So I could see that. It certainly would make that look faster, but I don't know that it would change. It would change for all the file systems, so I don't think it would just change for F2FS. Maybe if I had newer storage targets, something that was a little more that just came out. Maybe I get better results on newer things, but again, these are still pretty good enterprise style storage devices, so wouldn't expect a lot of difference. Especially with the SATA. SATA hasn't changed really, almost none at all. You're blocking, you're really blocking on the controller anyway. So um, anyway, I think this one is the one that I'm leaning toward the most. Mainstream file systems have probably kept pace. They have not stood still either. The folks that are out there working on these file systems are improving them all the time, and I think they've just maintained they've maintained their file systems and done some of the same things that F2FS is doing, as far as as far as being able to support flash file systems. So that's a possibility. Should I try a different distro? Well, maybe, and that might not be a terrible thing to go back and maybe give another shot at. Maybe I would get some slightly different results. But again, I was just keeping everything the same across the board there, so I'm not too worried about that one, really. So what are my takeaways from this? I would just stick with XFS most of the time on flash storage. I think that's what I'm going to wind up doing, which is just using XFS for everything that I use it's going to be on flash. I can't imagine myself building a system with a spinner anymore at this point in time. There's just really no need to do that. So I will probably just stick with XFS for most everything. EXT2 or EXT4 is also a very fine choice. It's more of a religious kind of thing. Do you like XFS better, or do you like EXT4 better? It's kind of your choice. I would avoid, especially for if you're trying to get the best performance out of something, I would probably avoid ButterFS and F2FS as far as I can see. I would certainly avoid ButterFS for the high speed performance. However, I'm going to use ButterFS for my OS. I love the ability to do snapshots and rollback. Saved my butt more than once. For the actual OS to live on, ButterFS is my choice, and I'm going to stay there. But if I've got file systems I'm going to put a database on, or I'm going to put even/home on, where I'm going to be doing video editing or audio editing or whatever I might be doing that would require faster speeds, I'm probably going to use XFS for that. And I would say I'm going to do that until somebody else can prove me otherwise. So right now, that's my conclusion, where I'm at. Other caveats to keep in mind about F2FS. There is some, if you do go off and start playing with it, there are a lot of warnings out there about portability between systems. If you build your F2FS on an older system, on an older kernel, and then try to move it to a newer kernel, there has been a bunch of reports of it not working very well, and some real problems. There's also been a bunch of, I guess the support in Arch is pretty good for F2FS, but they have a bunch of caveats out there. If you use it, be careful if you're using it on a system where you have sudden power losses. The F2FS is kind of weak and has some issues. So you might want to use other choices if you're in a place where power loss is a problem. So, and then there's some other reports out there about Grub not being able to support things right with different flags set. So just some caveats to keep in mind if you start playing around with this. That's basically my slides. Any questions from anyone about any of this stuff? And if you go out to GitLab, to that address there, you could pull down all the the FIO tests that I used, and I think I've got the results out there as well. So if you want to go out and look at them, yes. Can I get you the Thank you, sir. Appreciate it.
Does it slow down the file system wear any compared to other file systems? Like, will the flash last longer?
I didn't get that impression from what I was reading that was really a big advantage of that. I didn't see that to be the case necessarily. And again, I guess one of the things I should have mentioned too, there may be things going on inside of these things that really help you to be able to use the flash-friendly file system better. Because this is not standard. Does not look like what a laptop looks like, or a server or a desktop system. So maybe there's stuff going on in there that, I mean, Google's got to be supporting this for some reason. Yeah, I would think, right? But I just don't see it on standard systems. Not sure. Any other questions?
Do the NVMe drives have any statistics on their lifespan that you can access?
Almost every one does, absolutely. So one of the things, I got this when I was working for SUSE, I got this reputation amongst my teammates and sort of extended team that I knew about devices and things like that. And people would be sending me things like, say, should I buy this thing? Or they would be going to use it for something. Go grab the data sheets. The data sheet, and you have to go look for the data sheets. A lot of times the device manufacturers don't prominently display their data sheets, but you can find them on just about everything if you go digging around a little bit. Go dig into the data sheet, and you can find in there what the expected lifespan is. How many petabytes can I write to this device over its lifetime? I would tell you that the biggest thing to watch out for when you're buying an NVMe device or you're buying any kind of a flash device like that is be very careful of buying anything built with QLC NAND. That is that's the quad layer NAND, where you're actually storing more 4 bits in a cell. That is QLC is you have to be very cautious around QLC. If your workload is such that you're writing out to it and you're just archiving stuff, QLC is probably fine. But if you're hitting it at all very often, you're probably going to wear out QLC pretty fast. And that applies to NVMe or SATA or whatever that you're doing there. So just be very wary of QLC devices. They can definitely give you a bad day. That's something I would tell you to watch out for. But if you go find the data sheets, it'll tell you the endurance of the device. I know Fusion IO used to prominently display that. We had our data sheets available to just about anybody that wanted to grab them. But I know on some of them it's hard to find them. You do definitely have to dig to get the data sheets. Other questions?
We had a similar discussion at the Annapolis Linux Users Group last week as, which is the best file system, ButterFS, ext4, whatever. Your numbers didn't differ an awful lot between the different file systems.
That makes me feel good. Thank you.
Well, what you did find, and I think is probably the takeaway for most of these type of discussions, is it has to do with how many PCI lanes you have available.
Absolutely, yes.
So it's, look at ButterFS maybe because of its rollback capability, but other than that, don't worry about it. Whatever has the particular flavor that you like, but just give it a lot of PCI.
Yeah, absolutely. There's no question that for an NVMe device, that's what you need to do, for sure.
You seem to prefer XFS over ext4. Why is that?
And I'm not even sure I can tell you why. It's more of I've gotten very comfortable with it. I've never had it do anything horrible to me. And I've always gotten good performance out of it. I guess that I don't see any reason to rock the boat. Maybe that's more where that comes from.
So I have been running XFS on my mini server.
Okay.
My mini server is 6 external hard drives and a not a Raspberry Pi. Can't even think of the name of the computer, but I noticed with XFS I was able to squeak more space out of the drive as well
Okay.
versus ext4.
Okay. I hadn't noticed that, but that's an interesting point.
You buy an 8 terabyte drive and you only get 7 point something out
Right.
of it with ext.
After you
get
format it and everything.
almost 8 with XFS.
Cool. Very cool. I might add that to the mix of tests to do, just to see how that comes in. I had never even thought about that. Very neat. It's not like it used to be, though. I'll go back to just a quickie little story. I used to work for Sun Microsystems back in the 90s, and I always wanted to have my own Sun workstation. And through the employee discount plan, I could have almost justified buying one because it was pretty good price. The problem that I ran into at the time was I knew enough about Solaris and SunOS before that to know that to make the thing useful, I needed probably 3 gigabytes of storage. Not 30, not 300, 3. And to get 3 gigabytes of storage in 1992 was going to cost about $3,000. And I just couldn't justify sinking that much money into it. And I never did. So the only piece of Sun gear I ever bought was a 1/4-inch tape drive, and I still have it. There may be, there is actually a Sun branded hard drive set back there that somebody had. So I'm curious to take a look at it this evening to see what it actually is. But that was why I could never justify buying a Sun workstation, was I couldn't get enough storage to make it useful. Other questions? Well, I'm actually finishing a little bit early. I had one more slide. This is sort of the bonus topic slide. People play with NVMe a lot and they wonder, well, how does this thing actually work? What is it actually doing? And so I used to work for Fusion IO. And if you're familiar with Fusion IO got bought by SanDisk in 2014. Fusion sort of invented this idea of putting flash on PCIe. And that was the whole idea that they had. Intel came along and was sort of jealous of all the money Fusion IO was making. And because they were making a lot at that time, from like 2010 to 2015. And so they basically came up with they reverse engineered what Fusion IO was doing. And that became NVMe. Once NVMe released, the sales of the Fusion IO products started dropping like crazy, and that sunk both Fusion IO and SanDisk at that point in the time. But the way NVMe works, it works just like Fusion IO does. That most of the brains of what you're doing in the storage actually runs on the host. So the faster the host goes, the faster the storage goes, for the most part, unless you run into that PCIe problem that we were talking about before. If you run into that barrier, that it's going to be limited by the processing power on the system. What we used to say at Fusion IO was, to get the maximum performance out of a piece of storage, use the fastest processor you can use, which is probably the processor on the host, not a processor in a controller. And so that's the whole idea behind it. You put most of the brains of what's going on in the storage in the CPU and the RAM. And at the time, there were all kinds of systems that were sitting out there running at, 80, at 50% utilization. They had lots of cores that were sitting there doing nothing most of the time. Why not use that for storage and take advantage of those cores that are sitting there doing nothing? And that was a pretty good argument. And NVMe works in exactly the same way. That most of the brains that's going on is in the driver that's actually running on the system. And the PCIe device is just sort of the endpoint. So that's the sort of the key thing there. Also, and I used to get this question a lot, so I was going to throw this in here as well. A lot of people equate NVMe devices with M.2. They think that's NVMe, right? M.2 is not a device. M.2 is a form factor. You can get SATA in that. NVMe comes in M.2, EDSFF, which is the longer sticks. I've never actually seen those in a system. I know we talked about them when I was at SanDisk, but I never actually have seen them. And in add-in cards. You can still buy add-in cards today. So those are still available. But M.2 has become the preferred way of doing it, which is fine. It's perfectly okay. Just not very hot swappable, but works okay. Sorry. I'm sorry?
Wear leveling still happens on the controller?
Actually, wear leveling is really going on in the driver itself. So it's going on all over the place. Yeah, it in most cases with NVMe there really is no controller. I mean, it's not like a SATA thing where you're actually having a SATA device. We always usually jokingly say a SATA device is like a little computer. It really is. I mean, the ASIC running inside of the SATA device controls everything, so it's doing all the work, and it's not even a very fast computer. So, other questions? Well, I'll be around today and tomorrow. So if you want to talk more about storage devices or any of the stuff SUSE-wise that was going on, I still remember most of it anyway. Also, there are some keychains up here that the KeyBio people sent. So if you want to grab one before you take off, and I urge you, if you're looking for a mechanical keyboard, give these guys a look. I like to support local businesses. So other than that, thanks. Thank you.